In this section, we are going to derive the ideal gas law. So in previous sections, we have ignored the amount, which is moles, of a gas that is present in a system. We will no longer ignore that. What we did learn in section 5 was that if you're at STP conditions and you have 1 mole of any gas, it is 22.4 liters in size. Now that can vary though, because you don't always have 1 mole. Sometimes you have more, sometimes you have less. And so to figure out the volume of a gas, all we need to do is take that 22.4 and multiply it by the number of moles present. So deriving the ideal gas law, we're going to use that idea. So suppose we have a gas that's at STP and then the conditions are changed to some unknown values. So what we're going to do is we're going to start with the ideal gas law, and we're going to plug some of these STP numbers into the equation, and we're going to see what comes out of it. So there's our ideal gas law. Now, the pressure would be 101.3 kilopascals. Now, our volume, as we learned in section 5, is 22.4, but that depends on the number of moles that are present. And our temperature at STP is 273.15. Now, if we go and grab a calculator quickly and go 101.3 times 22 times 273.15, you should get approximately 8.31. I think it rounds a little bit, but if you were to get an exact number, as scientists have, you get 8.3145. Now, this moles is still present. We've not kind of dealt with it here, but this 8.3145 that we simplified is an important number. It's so important that we're going to use the letter R to classify it, because this is in fact the universal gas constant. Let's simplify this a little bit more here. So that's as far as we got. Now what we want to do is we want to get rid of this n. This n's no good on this side here. So let's divide both sides by n, and we'll simplify our gas law here. Now the only reason we've done this is so that we can actually investigate the units that go with this 8.3145. Now, this is equal to everything on this side, so if we just simply look at the units of the P, V, T, and N that are present here, we should know the units of this 8.3145. So, the units of P at STP, we used kilopascals. Now, that's important because there's a few different pressure terms out there. So this means that anytime you're doing a question using the ideal gas law, you want to be working in kilopascals. Now, when we derived earlier, we used 22.4 liters, so our volume is in liters. On the bottom here, our temperature is always in kelvins, you need to convert. And lastly, we have moles. So all this stuff right here, these 4 units, these are the units of the gas constant. We're not going to need to carry these units along. As long as we know they're there, it's going to help us solve problems. So once again, I want to simplify this gas law here. So all this stuff that we've written on the right side of this arrow right now, we're going to use the letter R to represent it. And there it is. Now we're going to simplify our gas law a little bit, and all we're going to do is we're going to take this T and N here, and we're going to multiply it up to the right-hand side. So really our final gas law is going to look like this. Pressure times volume will be equal to the number of moles times our gas constant times temperature. This is the ideal gas law. So anytime you see a question involving moles, you want to use the ideal gas law. Don't forget, we always know what R is. It's 8.3145. So let's go ahead and take a look at a problem, and let's apply the ideal gas law to it. So example, what volume will 15 grams? Now, as soon as you see something in grams in the gas section, you can find the moles, which means you're using the ideal gas law. So let's read on here. We've got something at 300 kelvins, so that's going to be our temperature. And we have a pressure of 1 atmosphere. Now that causes a little problem right off the bat that we're going to deal with. So once you realize that you do need the ideal gas law, which is that. Okay, so let's start off with our pressure. Pressure is equal to, now we've got it as 1 atmospheres here, but you got to remember, back when we derived the gas law, we used kilopascals. So really what we're going to have to do is convert this 1 atmospheres to kilopascals. And I just picked an easy one here because 1 atmosphere is equal to 101.3 kilopascals. So there's really no conversion as long as you understand that it's basically the straight up conversion there. So that is our pressure, 101.3 kilopascals. If this weren't 1 atmosphere, if it were 2.5, then you'd multiply 101.3 times 2.5 to get the pressure you need to continue with here. But anyway, that one's should be straightforward, I hope. The next thing is our volume. That's what our question's asking us to find. Next is N. Now, do we actually have a value that gives us N in this question? We have this 10 grams, but that's grams. That's not moles. So we don't actually know our moles, but we should be intelligent enough by now to go ahead and find the moles of argon, setting it equal to those 10 grams of argon times, on the bottom we're going to have our 40 grams of argon. That's about the molar mass. Those cancel out, and that's 1 mole. So 10 times 1 divided by 40 should give us 0.25. So that 0.25 is actually how many moles we've got for this question. So finishing off here, R, don't forget it's always 8.3145, and it has that crazy unit, but I'm not going to write it. And lastly, T for temperature, it's 300 kelvins. It's not in Celsius. If it were in Celsius, I would convert to kelvins, but it's already in kelvins, so let's just proceed. So let's write our ideal gas law. Now we're going to solve for volume, so we'll divide both sides by P. There you go. And now it's just a matter of plugging in the numbers that we have written down. 0.25, 8.3145, 300, and divide that by 101.3. So if you grab your calculators here and type it all in, you should get 6.155, blah, blah. I rounded it here a little bit. Now I guess the question is, what would the units of this volume be? Well, let's not forget here that our gas constant was derived using liters. So that means our answer is in liters. So other questions are out there that are going to say ask for pressure. And you got to remember that if you're solving a question for pressure, this gas constant was derived using kilopascals, meaning your answer will come out as kilopascals. If you do one for temperature, it should come out in kelvins, and kind of so on there. So that's one example of the ideal gas law. Again, remember, if you see something with grams in this unit, you're finding the moles, you're probably using the ideal gas law.